Okay, so now we're going to move on to solids. Okay, and in class lecture 26, we talked about different types of solids, and you can refer to the notes. So we're going to compare different solids and classify them based on the different types of solids that they can be. So erase our board here. Okay, so our first substance that we have is sodium. So Na. So sodium is a metal. So we would expect sodium to form, of course, a metallic solid. So all metals will form metallic solids. Okay, our next example here is boron. So if you look at the periodic table, I have a nice one up here. Boron is not a metal, it's a metalloid or semi-metal. And in class, I said that if you have a metalloid or carbon, you would expect or predict those to form covalent network solids. Okay, and covalent network solids, just to remind you, are essentially they're solids that are very big molecules, meaning that every atom in a covalent network solid is covalently bonded to another molecule, another atom. So all metalloids plus carbon tends to form covalent network solids, will be a covalent network solid. So you should be able to identify those as covalent network solids. Okay, our next example is ethanol. And ethanol, I'll draw a Lewis structure for you. Just draw a regular Lewis structure. Okay, so ethanol, if you want to classify this type of compound, it's a molecular compound. So if you remember way back from the beginning of the term, molecular compounds are compounds that are made of nonmetals. So if you have a molecular compound, you would expect the molecular compound to form a molecular solid. Okay, and finally, we'll write this over here, we have potassium fluoride, KF. So KF is an ionic compound made from a metal and a nonmetal. And ionic compounds will, of course, form ionic solids. Now, one question I posed to students in class today was that how could we compare the melting points? So we're going to leave sodium out of this because metals tend to have a large range of melting points. There are metals that, like gallium, that can melt if you have them sitting in your hand. And there are metals like tungsten, which have very high melting points. I think tungsten does have the highest melting point of all the metals. This is why we use it in incandescent light bulbs. So if we compare the melting points between boron, ethanol, and potassium fluoride, we would expect boron to have the highest melting point, MP. So because covalent network solids are, once again, they're essentially very big molecules. All the atoms are covalently bonded. It takes a lot of energy to break a covalent bond. So we would expect boron and all covalent network solids to have the highest melting points when comparing different solids. Ethanol will have the lowest melting point. So molecules in molecular solids are held together by intermolecular forces. So intermolecular forces are not chemical bonds in any sense. They're just interactions, very weak interactions between molecules. So it doesn't take as much energy. It takes the least amount of energy to break up intermolecular forces. So since molecular solids are held together by intermolecular forces, we would expect ethanol to have the lowest melting point when comparing different types of solids. And then finally, so ionic compounds. So the ionic compound KF will have, I guess we can call that the middle melting point. So the ions, potassium and fluoride ions, are held together by Coulomb interactions or electrostatic interactions. So those are interactions between charged particles. So we would expect since those interactions, although they're pretty strong, are not as strong as a covalent bond is. So we would expect that for KF to have the moderate melting point, so melting point in between that of boron and ethanol. And again, sodium, we're not going to compare that because we really can't compare metals since they have a large range of melting points. But you will be asked to compare covalent network solids, molecular solids, and ionic solids in terms of melting point strength. And in addition, you could be asked to compare different molecular compounds in terms of melting point. So you would expect, again, just like with the boiling points, molecular compounds that have more intermolecular forces will have higher melting points than those molecules with less intermolecular forces. Okay, and that's it. So talking about comparing different types of solids and different substances by looking at the interactions between their constituent particles.